Well, hello and welcome to the Smells Like Money podcast. Join me, Suzanne Chin Taylor, the DooDoo Diva, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. As a veteran of the wastewater, trenchless, and civil infrastructure industry, each week I'll be bringing you industry know-how from industry pros who know how. Join me each week as I speak with representatives of organizations that are utilizing disruptive or new technologies and methods, and executives who are excited to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology, in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. Ready? Let's dive right in. Well, hello and welcome to this week's episode of the DooDoo Divas Smells Like Money podcast. We are continuing our visit with Greg Budzinsky, the founder of IT/OT Systems, and we are continuing that dialogue that we had on the last episode about PLCs and PACs and steps that we're taking to move into the next century or maybe the current century with technology to make our systems basically just more efficient and to run better. But we can't go in just, with rose-colored glasses, as Greg and I have been discussing, that we kind of have to be aware of some of the limitations of what we've got and how they're all going to work together, how they're all going to talk together. And I'm going to let him explain because we thought of a great comparison. We talked about this is kind of like an Alexa system for your wastewater treatment plant or water treatment plant. But just like your home, for any of you who have an Alexa system, you may have run into those issues where you've got all these smart devices, but they don't always seamlessly speak to one another or work as well as they should together. And so, Greg, we started talking about that. I'm going to let you take it from here because it was just a great analogy that you provided me.
Well, thank you, Susan, for having me back, and it's great to see you again. Yeah, and so from a control standpoint, we talk about PLCs, we talk about PACs. Those are oftentimes very customized for the implementation, whether or not that's the vendor of the controller that you're using, or if it's the manufacturer of the piece of equipment. They oftentimes have their own standards, protocols, and ways of handling certain process type environment actions that are required within any sort of environment. You have a modular valve that needs to be controlled to a position. Company A might write the code differently than company B. So if you have two separate pieces of equipment in your facility, oftentimes you're not necessarily going to get the same data set, and you're almost never going to have the exact same code written for that device within both of those pieces of equipment. And that's a lot like what we deal with on a personal level every day. Is you may have a smart TV in your house, or you may have a smart device, a speaker, whether or not it's Alexa or Google or Apple or whichever major name brand you want to go with, or even an off brand. But those devices don't talk to each other on the same language or even in the same capacity. So one command to a specific device or a different type of manufacturer could be a completely different command for another manufacturer. Now there's strides being taken in that realm of trying to establish a standard protocol specifically for TVs. But when we're talking about water, wastewater facilities, or any type of industrial control system environment, what needs to happen throughout the industry is the implementation of standard logic blocks that are able to handle the standard process object ways and devices of performing these actions that are typical within any sort of environment. So you may have a control action that you need to take in the field that is either operating a valve or turning on and off a pump. And then there's other layers of logic that stack on top of that. And that comes into having lead lag operation, even distribution of flow a lot of times is a high concern for facilities. And having a standard methodology for performing those type of actions needs to be established throughout the industry. And that's one thing that at ITOT Systems, we try to help facilities make sure that we start to create that. And we do that in a way to ensure that the way that you're implementing your systems and your code is updatable. Just like all these other devices that we're using from a smart device standpoint, the logic, the applications, everything involved with that device and the devices that are on top of that device for supervisory purposes need to be updatable.
So when you talk about updates, one of the things that it drives me batty is you've got the smartphone. I love my iPhone. I love my devices. Everything's running just great. And then all of a sudden they come up with an update. And maybe there were some bugs, maybe there were some security issues that had to be fixed. But then they changed something else within the system. So now this function that you had on the iOS that you were so familiar with, that you knew where it was, you knew how to turn it on, you knew how to set, all of a sudden now it's gone. It's moved to another spot. You have to go hunt and find it. And then when you do find it, you recognize that, wait a minute, it doesn't operate the way that it once did. And so now it's more complex. It's more cumbersome. Whereas before I just had to change this. It's like, okay, so how do you deal with those situations where the manufacturer of a particular piece of equipment that you're using has to make an update to the controls for whatever reason they decide that they're making it bigger, better, faster, more? How do you deal with those things where that update's coming from somewhere it's completely out of your control, to make sure that things are still going to behave nicely and that the operators are not going to go crazy trying to figure out how to make something work when they knew at it always worked this way, and now they want me to do something different to make it do the same thing that it did before. So how do we combat that? How do we get around that?
Absolutely. That is the ultimate catch-22 of transitioning from or into a smart device or a smart facility, whether or not it's for a particular piece of equipment, a particular device. But what you are able to do from a logic standpoint, and we've shown this on the IT side when we're developing applications, there's databases that house certain sections of code, and those sections of code get updated. And then any application that's written that references that code block gets updated along with it. And that's the methodology that we're trying to promote and that we're consulting with our clients to make sure that their systems are designed in that fashion. And you do run into that concern where it used to work this way, or now we have a bug in the software. And so with operational technology, the number one thing behind operational technology is availability and functionality. You need to make sure that when the pump is commanded to turn on, it turns on. And that leads to why the systems are designed the way they are and why the logic is so important, to make sure that you're not updating it or changing it so that the operations departments around this space don't run into those types of issues. And so you have high vetting of any logic change that's going to be implemented. And you want to make sure that you have good operator training processes put in place for any time that there is a major change. And most of the time, those are going to be centered around the graphical user interface for the SCADA environment that you're working with. So if you have a change that's coming in that's going to move a command source button to be able to take a device in the field from automated or an automatic control to manual control, you need to make sure that that's well trained. But you also need to make sure that the graphical interface is simplistic, or as simple as the user needs. So that leads into establishing this layer of code and of graphics that is universal to a process environment. And I keep talking about this, but you have generic device statuses, you have generic values coming in from a facility. And that all is going to happen at the operational layer of logic. And those types of values, the interactions that either an operator, a mechanic, or an engineer, or even electrician is going to have with the device, can all be brought into this generic layer of code where any handling of alarms, of capabilities, any functionality that you want built in or capability into the software package or the application is all done the same across your facility. And then beneath that, you have your device layer. And each device should have the same format of code, but they're not always going to share the same protocols. They're not always going to share the same capabilities. One valve is not from a manufacturer is not going to have the same data sources as from another manufacturer. And they're probably not going to be in the same registers. But each one of those code blocks has to be updatable. So as the vendor updates their device with new firmware, you install a new device, you are able to update that device layer logic while your operational layer logic stays the same from an operator facing standpoint.
So when you say update, is that meaning that the plant would need to have code written for this? Or explain to me what you mean. How does that update take place?
Yeah, that's the complicated part, and there's a lot about that when it comes to industrial control systems, because we're not just talking about updates for the logic as well. When it comes to updates, you also need to update firmware of your devices, and that includes your controllers and any of the communication modules related to those controllers. And when you perform an update, it needs to be limited to the area within the facility that can be supported during the update, because you don't want to have, you don't want to mass update your whole facility and then have a bug in the code. And so there are methods and architectures where you can classify different areas, and there's lines of demarcation for most facilities and based on the implementation of the controller locations and the amount of space and the number of devices that each controller is responsible for.
Okay.
And so we provide knowledge in making sure that updates are done to either sections of code or to entire controllers or even an entire subset of controllers based on the amount that a facility wants to handle for a given day or a given week.
Is that kind of what you meant by continuity of access, or is that something different?
Continuity of access.
Yes, is that making sure that things, I guess it was that standardization of the code, making sure they all spoke the same language, so continuity of access across all the devices, where you were saying that underlying thing needs to be generic enough.
Yeah. And so that touches a little bit on continuity of access, but in general, when we're talking about continuity, we're talking about the presentation of the generic section of code that's going to have interaction with an operator, or it's going to perform a function within the logic itself. And so that could be providing a permissive to a pump where you have various inputs from the facility or from that piece of equipment in order for it to start. And then you have another block called an interlock block, where if you have a device failure or an alarm condition come in, then that piece of equipment or that pump or the device stops whatever it's doing. That could be safety related, that could be equipment protection related. But the continuity that you want to make sure that you have is that when you're doing updates, you want to be able to handle the entire facility. So if you want to add a new capability, let's say there's a new data analysis that we want to have for gathering a point and providing an operator notification based off of variation in the pump speed. So now we're going to monitor how fast has the pump been running in the last hour. Did it change by a certain percentage? So we want to add that capability to every single logic block that monitors pump speed and has that interaction or performs the logic necessary to have that pump run and all of the other operator interactions within that pump. We want to be able to update that throughout the entire facility in a fairly succinct and efficient manner. So that way you have continuity of the expectations from both the maintenance department, the operations department, and the engineering department, that all of these pieces of equipment are controlled by the same logic set.
So that leads me to, you had mentioned to me about the pitfalls of program Rewrites. And what do you mean by that? People trying to do things piecemeal, little by little. And I remember you were saying to me earlier that that could be a very costly endeavor if you have to try to rewrite it to fit your needs or to make it talk to each other.
Yeah, and development of every single one of these applications for a controller that's on the edge is not a small task. You
Okay.
have a multitude of devices that you have to interact with, and as smart devices have come into the to play, you oftentimes have a lot of research and reading over white papers to be able to provide the communication from that device, even at the most simple of levels. For like a temperature transmitter to be able to read the temperature and then read also the fault code, or device status code, sometimes as it's called, to be able to provide all the information from that smart device, it all takes time. And rewriting a program to get into the standardization form, a lot of controls engineers end up repeating that same work every time you implement a new device versus having that code block provided by the manufacturer. And this is because there's multiple control systems vendors. They don't know what your implementation is going to be necessarily, but there is progress being made on this. Some of the large device manufacturers, especially for process environments, are providing their own subsections of code for specific vendor control systems. And that's a good step in the right direction, but they're not doing it all the same. So we're running into the same issues that we're having, from the building, but we're making progress. And from a pitfall standpoint, one of the things that you run into when you're rewriting old code is you have two options. You can either A, try to analyze the code and make sure that everything that was done in the code is repeated in the new logic, whether or not that's done through an automated process or through a manual process. And that comes with its own pitfalls of you could be bringing in bugs or old sections of code that weren't even used or are now obsolete. And then you have the other option of starting from scratch, where you may take the device layer logic code blocks from the old program, but you're going to completely rewrite the operational code based off of a set of documentation that says this is how the piece of equipment is supposed to write. Oftentimes that's called standard operating procedure for whatever the piece of equipment is.
Okay. Well, I'd like to close out this episode with, there's a lot, there's so much that could be discussed on this, but I'd like to end with this topic of layers of logic that you told me about and stacking them. And because you mentioned that earlier about, stacking logic. And the three parts of that are the device, operational, and algorithmic. And maybe if you could weave those together as to how it applies to a wastewater treatment plant and devices, all in all, and why taking this approach is so important.
Yeah. So categorizing the different types of logic that you're going to be implementing really allows you to draw those boundaries between the types of interactions that you're going to have between the logic and the user, the logic and the device, or between the layers themselves. So from a device layer logic, oftentimes, historically, that's been as simple as scaling an analog input that's coming into a controller card that provides a milliamp signal from a particular device. Now we have smart devices, and that logic set has grown quite extensively. You could have configuration capabilities within your system based on the device logic that you write. And ensuring that that is segmented away from your operational layer logic allows that updatability of that code section. So that way you can provide this implementation of a new logic set at your entire facility without disrupting all of the other subset of logic that's been written for providing, pump control, valve control, and general control or process control of an area or of your facility or within your facility by updating the device layer logic. And that's one of the critical things that if you can do that off the start, Getting to the operational logic layer then allows you to establish over time that generic approach of here are the standard process objects that we have within our facility. And that is facility agnostic. You could be a conveyance facility or warehouse type facility from a material handling standpoint. So you have conveyors, you have sorters, you may even have palletizers, versus water wastewater, where you have valves, you have motors, variable speed motors, and you have temperature transmitters that create these standard objects of an analog signal or a discrete signal, or even lead lag. So if you have 5 pumps, you want to have a standard way of doing a 5-pump lead lag sequence, as you do with your 3-pump lead lag sequence. And that logic block should contain all the different variable options that you want to see or capabilities. So if you want to have a lead and then a lag 1, a lag 2, or if you just want to have a lead and then everything else be standby, and then whichever one is available comes on in a preset order. All of those logic blocks should be the same, and they should be built around the same functional structure. And then you get into your algorithmic layer logic, which most people just consider to be a PID, or proportional integral derivative. That's been a widely used algorithm throughout the history of process control, going all the way back to the 1920s, where a feedback loop looks at the error between what the current value in the field is and what the set point is. And the PID handles that very beautifully. But that's our first step of algorithmic logic layer. We're getting into the field of data science now, where there's lots of talk about data and how it can be used. And not all of that is going to be used for control. So you want to make sure that all of your control aspects of any of your logic, whether or not that's at the device layer, the operational layer, or the algorithmic layer, are as close to that field device as possible, or on your edge compute resource. But your algorithmic logic for performing data analysis on assets, on your performance, don't necessarily reflect back into control of your facility. They might just be generating reports or recommendations. So that logic layer can live up in the cloud or not as close to the edge, but because it's not providing any actual control of the field devices themselves.
Okay. Well, a lot to consider here as we are moving forward with technology and taking our wastewater treatment plants into the age of the Jetsons. I might be aging myself here. I never dreamed that when I was young and seeing, for those of you who are familiar with this, the Jetsons and people talking on the phone and seeing each other. And here we are in a Zoom meeting live. Absolutely. Never thought that I would see that day, and here we are. And all of the different things that we dream of, that we think were never going to be a possibility, are now right here at our fingertips. And it's just an exciting time, I think, to watch what's going to unfold just to make things better for our industry. And so if you are listening and are interested in looking at this technology, making sure that you implement these processes correctly, that maybe you've got some things in your plant that you're doing already, but you want to take it to the next level, or just need things, as we were talking about, to basically just play nicer together, to make it, less problematic when that firmware update comes down the pike and you're like, okay, why isn't this working the way that it should? Please call upon Greg and his team at IT OT Systems. And Greg, if you could please give us your website and email address for those who are interested, how they can get more information about how you're able to help them with this.
Absolutely. Thank you, Susan, for the time today. I know a lot of this is a dry subject for many people. Some people like myself, it's the most interesting thing that we can talk about. But if you're interested in having more conversations, just to see where your facility's at or how you could take next steps, you can visit us at itforot.com or email us at info@itforot.com.
And that's the number 4, not FOR. So IT, the number 4, OTsystems.com.
Yeah.
Well, again,
Both actually take you to us.
oh, do they? Oh, that's great. That's great. All right. So whichever way you remember it, it's there. And in the show notes, we will be also including Greg's LinkedIn connection, where you can find him there for more information. And thank you again for being on the show, Greg, and sharing your knowledge with us. Like you said, it is a little bit technical for some people. It may be a little over their heads, but it's a subject that we need to be aware of, because it's something that, whether we're going to be doing it today or 2 years or 3 years from now, we need to be aware of it and becoming educated about it, because this is the way that it's going to go. This is just, we need to be more open to embracing technology, to, not that it's going to be replacing people, but it's just going to make our jobs easier and better as more and more things come online and more smart city initiatives become more of the norm rather than the rarity, that it's not just going to be for the big cities anymore. The small cities probably will benefit from it even more, because they don't have the budgets like the big cities do for lots and lots of people. That I just see this as, this is a good thing. All of this is going to be, it's going to be good for us. I truly believe that. And
Absolutely.
so again, yeah.
And
so thank you again, everybody.
Thing.
Yeah.
Sorry, that's the thing that we preach, is that that updatability really allows you to move into that next level, because you're not going to be concerned about getting overcommitted into this complex system that then requires too much time to maintain. So I'm really excited to talk about it, and we're really excited to help the industry move into what we call now Industry 4.0.
Right, that it doesn't have to be this complex thing that you have to be afraid of. You don't need to be a computer programmer to incorporate this. You just need the right tools and the right people, like Greg, and getting yourself educated. And so again, thank you for tuning in to this week's episode, and until next time, keep it flowing. Thanks so much for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. What stood out to you this week? Share your takeaways by leaving me a review. You can find out more about the new technologies, creating sustainable solutions, and insights on how to succeed in our vital industry by subscribing to the show. Whether you want to learn about the latest trends in wastewater infrastructure, treatment, or trenchless, you've got it all right here at Smells Like Money. If you're an industry expert and would like to be considered as a guest for the show, book a quick chat with me by visiting calendly.com/thetwoodgroup/B-A-podcast-guest, or simply click the link in the show notes below. Until next week, a big shout out to all my industry friends and those who will be. You are my superheroes. Thanks for tuning in, keeping it flowing, and we'll see you all next week.